This is the second classical problem that we'll see today. That is called, producer-consumer problem was the first problem. Second problem is readers-writer problem. This particular problem is, let me tell you the problem and then we'll go to the solution. Now, what is the readers-writer problem? The readers-writer problem is like this. We have a file, right? One file, and in this particular file, we can allow to read as well as to write. Let's say there are some people who want to read and there are some people who want to write. Now the problem here comes, you know about the databases, right? In the databases, if somebody is writing on the database on a particular data, so we'll allow it, but if another a transaction want to write on the same database, we do not allow it. Okay, we generally do that. So here also you consider as a file, and in this particular file, to read process want to read this particular file. So what we do? Let's say already this particular process, let's say R1, which is a read one, this is a read two, this is a write one, and this is a write two. Okay, let's say read one is already reading the file. So can we allow another read to read it? So the answer is yes, we can allow another read process to read that particular file, because reading the file simultaneously is not at all a problem. Now come to the second scenario. The second scenario is, let's say R1 is reading that particular file and W1 want to write into the file. Can we allow this scenario? If somebody is reading and another process came and it want to write on the file, can we allow it? So the answer is no, we do not allow it. It will be a conflict. What is a conflict? Is a read-write conflict. So there are conflict like read-write conflict. There are conflict like write-write conflict. And these two scenarios we do not allow. We can allow this. Read is possible. There is no issue on that. If somebody is reading and another process want to read, we'll allow it. But somebody is writing and another process want to read, that is also not allowed, right? Write-read is also not allowed. If somebody is writing, so we do not allow any read operation to be performed. As well as if somebody is writing, so if we'll have another scenario where let's say W1 is writing and W2 also want to write on that particular file. So do we allow it? So here also we do not allow it, right? So this is the problem that we have. The problem is we have to do the process synchronization. So let's say we have 4 processes, 2 read process and 2 write process, and we have to synchronize among them. And this is your shared resource, right? This is your shared resource. So definitely when you want to reach the shared resource, you have to go along with the critical section. So this is the critical section part. You can see the critical section parts. The critical section is nothing but the part where 2 or more processes will share something, share some resources. So here file is the resource, and this file will be sharing among 4 processes, and there are different operation in these processes. So 2 processes are for write operation and 2 processes are for read operation. So here we allow some of the process to do their operation and will not allow some of the process simultaneously. So this is my problem, and the solution to the problem, I am just writing the solution to that particular problem. So I think the problem is clear to all of you, that you understood what we mean by the reader's writer problem. Let's go to the solution to this particular reader's writer problem. Okay. Now, what is the solution? The solution here is, with the help of semaphore, we can give the solution. So let's say I'll first, for the writer, I am writing the code. Means the process who used to do write operation. So for that, it is very simple. We have to use the wait signal, and we'll wait on the semaphore called WRT, and then we'll do the write operation. And then after the write operation, we'll make a signal on WRT. It's very simple. Okay. So WRT is a semaphore. If any process want to write on that, it has to do the wait operation. So definitely WRT is initialized with 1. When we do the wait operation, we have to see the semaphore, whatever we are passing, it should be greater than 0. So WRT is greater than 0. So wait operation will be performed and it will become -1, and then write operation will be performed. At the same time, let's say another process want to execute it, because WRT value is already 0. So that process is not at all allowed to enter into the critical section. And only after the processing of this W1 process, the signal will be called, and signal will just make a increment on the WRT, and then W2 can come and can execute. So it is a strict alternation we are following, that will not allow to write operation to write on the file. So this is the solution for the writer. Okay. Let's go to another solution for readers. Now, what is the solution for readers? So let's go to the solution. I'll write the solution and then I'll explain what we mean by that particular solution and how it works. So the first operation that a reader will perform is wait. And the semaphore that we are using here is the variable name mutex. Here we have an operation called read count, and we'll make it ++. Then we have a condition if read count is equal to 1, then we'll perform wait operation on WRT variable or WRT semaphore, and then we have to do signal on mutex. Then we have a read operation. Then there is a wait on mutex. Then we do read count --. We have a condition if read count is equal to 0, then we'll perform signal to write, and then we'll make a signal to mutex. Let's try to understand this particular code. So what is that code? In this particular code, we have two mutex. One is, two semaphore. One is mutex Another semaphore is WRT, which is for the write process, means the process who want to do the write operation for that. And there is another, we have a variable read count, and read count is nothing but a shared variable, you can say. So these two are the semaphore. The mutex value is initialized with 1, and WRT also initialized with 1. Okay, let's see, we have a write operation. Okay, R1. Can we allow the write operation into the file? Let's see what this code says. So whenever we do the write operation, this will be performed. Whenever we want to do read operation, read operation, this will be performed. Whenever we want to do write operation, this will be performed. Okay. So this is for the write operation. This is for the read operation. So let's say I am reading it. Okay. If I am reading the file, can we allow another process to write on it? We do not allow, right? So this is the first thing that we have to do. What is that? First is the wait mutex, means the mutex value will be wait, means it will be -1, become 0 for R1. And for R1, this is the shared resource, means it is global variable, you can say. The read count is initialized with 0. Now we are doing plus plus, so it will become 1. There is a condition. If read count is equal to 1, then we have to wait on WRT. Right now, because we have only one read operation and read count will become 1, so we have to do wait on WRT. So the WRT will become 0. Why we are doing that? We are doing that because if another process came in between, let's say W1, so if W1 will come, definitely we have to perform this code, right? But in this code, what is the first thing? First thing is wait WRT. So when we perform wait WRT, what is the semaphore value of WRT? It is 0 now. So because it is 0, it will be in a busy waiting and it cannot go to the write operation. Means any write process will not be allowed if already read process is there in the file, or if read process is performing its operation. So because R1 is already there, we do not allow W1 to go into the file. So that's why we have to do this wait operation. And after that, we have to make as a signal on mutex. Okay, signal on mutex. So this mutex will be signal by with 1. Now what is the meaning of that? The meaning is R1 is already there and it is reading, and read operation will be done on R1. But at the same time, R2 can come. Yes, it can come. And when it will come, it will do the same thing. It will wait here. It will wait here, and it will increase the count value. So whenever it will increase, because R2 came, the count value will become 2. And can it will go into that particular condition, because here read count is equal to 1, here it is equal to 2. So it cannot go there. It will not do any wait operation. Instead, it will do a signal on mutex. So the mutex, whatever it has been waited, now it will become 1. In that way, so R2 also can come here. So what it want to say is, in the file, any number of read operation can be performed. Any number of read operation can be performed. Let's say R1 want to go out. Let's say R1 want to go out. What it has to do? Read operation has been done with R1. It want to go. So it will do wait on mutex. So this wait, the mutex will become 0, and because we have already some read operation, right? But R1 want to go, it has to do mutex on wait operation on mutex, it will become 0. And then it has to do read count as minus minus. Let's say we have 4 already. So let's say we have 3 and we have 4 already. So right now it will become minus minus means it will become 3. So right now R1 is outside. Then this operation will perform if read count equal to 0. No, it is 3. So this particular code is not going to perform. Instead, signal is going to perform. So signal will become 1 here again. Let's say R2 want to go out. Let's say R2 want to go out. So R2 can go out. So what it has to do, it has to wait first, and then read count will be minus minus, and then the condition is read equal to 0. No, it is 2. Then signal is not going to perform on write. Instead, signal is going to perform on mutex. So R2 has also gone. Let's say R3 want to go out. It has already been read. So R3, if we R3 want to go out, it has to do wait operation and then read count minus minus, and then it has to see that read count equal to 0 or not. No, it is already 1. Then we have to do signal on mutex. It will be done on mutex. Now let's say R4 want to go out. So what will happen? It has to wait on mutex. It will become 0. Then it has to read minus minus. Now it will become 0. Then there is a if operation, read equal to 0. It means that when last read operation is coming out from the file, we can make it signal of write as 1, so that any other process, let's say W1, because it is doing a busy waiting, now because WRT will become 1, now W1 can come here in the file because no read operation is there. And then it has to do signal on mutex, it will become 1. So you can see here in this particular solution, if there is a file, if first read operation is done, then will not allow any read operation, sorry, any write operation. If first read operation is in the file, will not allow any write operation. So that we have to do this operation that is called wait on WRT. When all the read operation is performed, means no read operation is done, at that particular time we have to make WRT as 1, so that this write operation will be allowed here. So we have to bother about first read and last read. So what we do in first read will make WRT as 0, and what we do in last read will make WRT as 1. So when we going out, the last read operation going out from the file, will allow another write to perform on that. And when we do the write first read operation, when we want to enter into the file, we have to make WRT as 0, so that other write operation would not be performed. So I think this solution is clear to all of you. So the solution here is that if we have a file, will allow number of read operations, but we do not allow any write operation. Okay, and whenever there is no read operation, we can allow write operation. So this is the solution given by the semaphore. Here we are using two semaphore. One is a mutex, another is a write. These two are the semaphore, and it is of binary type. Okay, and then we have a read count. Read count is a shared variable, or you can say it is a critical section variable, which is an integer variable. It can go up to the number of read operation into the file. All right, so this is how it works. What is the problem in this particular solution? The problem is the starvation problem, that if all the time read operation is requested into the CPU and already one read operation is there, so write operation will not get the chance to go into the file and update the value. by writing on it. So that is a problem with this particular solution. Otherwise, the problem is the solution is providing us the mutual exclusion. It is also providing us the progress, means will allow different processes to go into the critical section. And about the bounded weight, there is actually no provision of bounded weight. If you want, you can give the solution, further solution for bounded weight also by increasing some of the variables. So this is a simple classical problem related to the reader's writer problem, and the solution is given you in the form of semaphore.